Hello,
Hey, how's it going?
I'm good.
Okay. So for today's warm-up, I have two more higher-end trigonometry questions. Item number one, use your calculator to get sine 90, and then tell me why that makes good sense. This is a weirder question, and if you have a hard time figuring out why the answer is what it is, try to draw it out, and I think you'll be able to make good sense of it. And then item number two, I have a triangle here, and notice it's like the question that I mentioned yesterday, where since I'm not giving you all of the necessary numbers, your answer isn't just a number that you could get from a calculator online. You actually need to be able to set this up and solve it. So what I'm asking you to do is I want you to solve for length C, which in this right-hand triangle is our hypotenuse, but I want you to solve for that hypotenuse using sine. Now, what I want you to notice is that there are two completely independent ways to do this that both give the correct answer. And so when I go over this, I'll be going over both of them. The deal is that you can get the answer to this question by taking the sine of either angle, but depending on which angle you choose to take the sine of, it's going to change the structure that your answer has. Take a few minutes to go over these two questions, then we'll go over them, and then all I got for y'all today is I'm going to post the solutions to the additional trigonometry practice I gave yesterday, which you should be rounding the corner on. You need to be able to answer all the questions on that page quickly and comfortably. And then if you have any questions on the two most recent homeworks, I can answer any and all of those. And once you get that additional trigonometry uploaded and I've checked it off, once you have my permission, you can then sign off early. But I'm going to be checking those first just to make sure that they are to my liking. Because like I said, real big about this section, no work, no credit.
Mr. Robinson, do we have for item number 2, do we have enough information to get a numerical value for C?
No, your answer is going to be an equation.
Okay.
Yeah. And the easiest way to check that is, in order to actually do trig, you need 3 values, and I'm only giving you 2. I'm only giving you 11 and 90 degrees. And since I'm only giving you 2 numbers, you can't solve for an answer. Whenever you're only given 2 numbers, your answer has to be an equation. You would need to know what x is or c is in order to define the other. But you can write an equation for x in terms of c. You can also write an equation for c in terms of x. And again, the whole point of this is so that I can guarantee that there are questions on the quiz and subsequent tests that a calculator can't help you with. Okay, let's go ahead and get going. Item number 1, use your calculator to get sine of 90 and then try and tell me why this makes sense. So easy part first, what is sine of 90?
1.
And this is a good way to make sure that your calculator is in degrees mode. In degrees mode, sine of 90 will give you back 1. And in radian mode, it'll give you not 1. You know, it'll give you something wacky. And so who wants to take a shot in terms of why that makes good sense? How come sine of 90 necessarily has to be 1?
Well, because sine is opposite over hypotenuse. And when you're looking at the 90 degrees, the opposite is always the hypotenuse. So just be always equal 1.
Spot on. So here's my 90-degree angle, and here's my hypotenuse. So according to ca TOA, when I assess my opposite over hypotenuse ratio, well, sine of 90 is telling me, okay, I need the opposite side from my 90-degree angle. The opposite side is the hypotenuse. Take the hypotenuse divided by, well, the hypotenuse, just because that's what SOHCAHTOA is telling us to do. Put h in the denominator, and h divided by h will always give us 1. Just kind of a fun fact, you know?
Does this work with any number or just 90?
This works with 90.
Okay.
Because it produces this particular ratio, yeah? Item number 2, we can solve for c in terms of x using sine by 2 completely different methods. And in this case, it's gonna require a few extra steps because I can't just write a ratio of sine x that involves c. Why not?
Because you won't get anything. It'll just be 2 variables.
No, I already said right off the bat that the answer to this question is an equation. And the point of asking questions like this is to guarantee that you have to do the work by hand so that you cannot use a calculator in order to solve the triangle. That doesn't mean that we can't solve it. It just means that the answer itself is an equation. How come I can't write a ratio for sine using angle x that involves c right off the bat? What ratio is sine?
Because it's opposite, sorry, it's opposite over hypotenuse, and we're not given that opposite length.
Right, so sine of x here would have to be opposite divided by hypotenuse. And I don't have this length, but can I define it?
You could big X.
I can define this length right here using the Pythagorean theorem.
Oh, my bad.
And if I were to use the Pythagorean theorem in order to get what this length here has to be, it's going to be equal to the square root of c squared minus 121. Now I did that in my head, but I expect that all of you can figure out where that comes from. Where does that come from?
Squared plus b squared equals c squared.
Yeah, so if we call this side here b, c squared is equal to b squared plus 11 squared. C squared is going to be equal to b squared plus 121, where we're solving for b. And so to solve for b, that'll be c squared minus 121 is equal to b squared, take the square root of both sides. B is equal to the square root of c squared minus 121. And so this side length here, well, that's b. So now I can go ahead and take sine of x, and I can be like, okay, I got sine of x. And this is going to be equal to what?
It's going to be equal to the square root of c squared minus 121 over c.
And now we have a statement which involves sines and c's. So one way I can solve this out is I could cross multiply, which will give me that c is going to be equal to the square root of c squared minus 121 over sine of x. And I would accept that as one possible answer, even though it involves defining c in terms of c. Is that okay for one possible solution?
Mr. Robinson,
Yes?
when you get sine of x is equal to c squared minus 121 over c, why did you put it over c?
Sine of an angle is equal to opposite over hypotenuse. Sine of an angle is equal to opposite over hypotenuse.
Oh, okay.
That is just the ratio of sine from SOHCAHTOA.
Okay.
Good question. What's another way I could do it? Is there another angle here that I could take sine of?
I did it a different way. It might be wrong. I did like cosine to find the missing side.
So you could do that. You could say cosine of x is equal to 11 over c, and then you would be done in terms of defining c. But I said use sine specifically. Like, it's mathematically correct, but if I say use sine, then use sine.
Okay.
Wait, should we give another solution for?
There is another solution because there's another sine that I could take. What's another sine that I could take in this triangle? How many acute angles does a triangle have?
2.
So we could use the one angle that's not given.
Right, because we know what it is. What does this angle have to be? How much is it?
$60?
Nope.
45.
No. All of the angles in a triangle add up to?
180.
180. So
What's this angle measurement?
90.
So what do these two angles have to add up to if this is already 90 out of 180?
it has to add up to 90.
These two angles, the two acute angles in a right triangle, they have to be complementary. So if this is x, what does this have to be?
45, which is also x.
You don't know that. If this is x and these two add up to 90, what does this have to be?
90 minus x.
90 minus x. If you have one angle of a right triangle, that other acute angle has to be 90 minus the other angle. If one is 30, the other is 60. If this is 1, this is 89. This equation is what locks these two together. So here's our other answer for solving for c using sine. Sine of 90 minus x is going to be equal to what ratio? So from this angle's perspective, sine is SOHCAHTOA.
Opposite over hypotenuse.
So from here, what is the opposite side?
11.
And the hypotenuse is still c. So sine of 90 minus x is 11 over c. Cross multiply, c is equal to 11 divided by sine of 90 minus x. I would assert that this second approach is much cleaner, much more straightforward. And so that is it for today's warm-up. To start off our workshop time, are there any questions from the most recent homework or from the second most recent homework? That is to say, either on the homework that I posted yesterday or on the 8.4 homework, the regular trig assignment, which I sent back to many of y'all for not showing work. if you have any questions on that stuff, now's your time to ask them.
Mr. Robinson, I had a question. Is the flashcard tomorrow required?
No.
Okay.
I posted the solutions for the homework that I posted yesterday so that you can check your work before you move along. Though, as I warned y'all, no work, no credit. So make sure that you show all of your scratch work before you turn that assignment in, yeah?
Mr. Allison,
Yes?
on the new homework, how do you solve? I don't know how to do 9. Is it the same way you do it as today's do now that we just did?
Question number 9. So we have this triangle, 37 degrees. This is 11 and this is x. Correct?
Yeah.
Yeah, so there's 2 different ways that you can solve this, 2 completely independent ways that this can be done. Number 1, we could use the 37-degree angle. So from this 37-degree angle's perspective, what is this side length called?
The adjacent
That's the adjacent. And what are we solving for?
hypotenuse.
So which ratio is made of adjacent and hypotenuse?
So cosine.
Good. And yeah, whenever in doubt, check SOHCAHTOA. So this is to say cos 37 is equal to adjacent over hypotenuse. Solve for x by cross multiplication. X is going to be equal to 11 divided by cosine of 37. So this is one way to get the correct answer. Here's another way. If that angle is 37, we know that the 2 acute angles in a right triangle always have to be complementary. So if that's 37, what's the other angle?
53.
This is necessarily 53. And from this angle's perspective, what is the length 11 called?
Opposite.
Opposite, and we want the hypotenuse. So which ratio, according to SOHCAHTOA, is made of opposite and hypotenuse?
Sine.
Sine.
Sine. So this is to say that sine 53 is equal to opposite divided by hypotenuse. And again, I can solve for x by cross multiplication. X is going to be equal to 11 divided by sine of 53. Now, of course, the second procedure is overkill, but the reason why I bother with it is to show you that it doesn't matter how you do this. The story of math is that as long as you choose a correct method and don't make any mistakes in executing the method, all roads lead to the same city. So this is to say that 11 divided by cosine 37 will give us the correct answer of 14.37. And it should be longer than that other side, right? Because the hypotenuse of a triangle is always the longest side. Or 11 divided by sine 53 gives us back the exact same. Ooh. What? Wait a minute.
Number 9, I got something different.
Mode. Oh. My calculator is in radians. Heck. Degrees. 11 divided by cosine of 37 gives us the correct answer of 13.77. And 11 divided by sine 53 also gives us back 13.77. Yeah. Make sure your calculator is in the correct mode. Mine was in radians because of what we were doing this morning in pre-cal. So both of these, yeah, they both give 13.77. 13.77.
Robinson, I'm not sure why, but for that one, I got like 0.07.
No, the hypotenuse has to be the longest side. So no matter what, your answer has to be bigger than 11.
Oh,
Mr. Robinson, I turned it in. So
Give me 1 second.
yeah.
Maria, check the way that you entered it in your calculator.
okay, I'm redoing it right now.
Mhm. Okay, yeah, you're good to go.
Okay, thank you. Have a
Yeah,
nice-
this looks fine. Yeah, take it easy.
Mr. Robinson, I also turned it in. Am I allowed to leave?
Yeah, looks good.
Okay. Bye, Mr. Robinson.
Bye, have a nice day. I'll see you tomorrow for the quiz.
You too.
I still got the same answer. I did, so to find x, I did cosine. So I did cosine 37 equals 11 over x.
You can't enter things into your calculator that way. Your calculator can't solve for x for you.
No, like I didn't put that into it, and then I multiplied it by 1 over 11 so that I would get the 11 out, and then I multiplied both sides by that.
You're doing cosine 37 divided by 11, not 11 divided by cosine 37. 11 divided by cosine 37 is the answer. You're doing cosine 37 divided by 11, which is giving you that decimal.
Oh, okay.
Cosine is equal to adjacent divided by hypotenuse. The adjacent side is 11, the hypotenuse is x. The act of solving for x will give you x is equal to 11 divided by cosine 37.
Oh, okay. What's the answer to number 12?
On the assignment that I put up yesterday,
Yeah.
one, the solutions are up on Classroom, and the answer to 12 is 5.5.
Oh, okay. So
Question
it's only that one that I'm getting wrong.
Question 12 is a 30, 60, 90 triangle. So that bottom side length should be exactly 1/2 of the hypotenuse. It's 11 divided by 2.
Oh,
For that one, you don't even need to do standard trig, though you could do standard trig for it. And if you did standard trig for it based on the 60, that side length that we're solving for, is that adjacent or opposite?
that one's adjacent.
And what side length did they give us?
They give you the hypotenuse,
So what ratio is made of adjacent and hypotenuse?
cosine.
So that question is saying that cosine of 60 is going to be equal to adjacent divided by hypotenuse, multiply both sides by 11 to get x. So 11 cosine 60 is equal to x. And if you feed that to your calculator, you get that x is equal to 5.5 because cosine of 60 is exactly 1/2.
Okay, thank you.
Either that or, special right triangle rules give the same result.
So if you solved an equation and you're gonna plug the like tangent thing into the calculator and you got 6 tan 28, then can you just put it in like that?
It depends a lot on what calculator you have. I can because my calculator knows that when I enter it that way that I'm asking it to multiply and that the 28 belongs to the tangent. But
Yeah,
in
please.
your calculator, what I expect you'll have to punch in is, I think you have to press 28 first, then you have to press tangent so that it takes tangent of 28, and then you press multiply by 6.
Yeah, I did it the way you did it and it worked.
Okay, yeah. What model do you use?
The Texas Instruments 30X Roman numeral 2S.
Oh, that's good. Yeah, that's the super common one that everybody uses. It's good to know that it understands parentheses.
Mm-hmm.
Yeah, people with Casios, a lot of the time, they'll have to input everything backwards. Because to do this, you would have to punch 60, then press cosine, then press 11. That's why I don't really like using any Casio calculator that's not like my wristwatch calculator.
Yeah.
Mr. Robinson, I turned in my work too.
Okay, hold on. Okay, looks good. Be sure to check your solutions against the one I posted, and you have a nice day. I'll see you tomorrow.
Okay, thank you.
Mhm.
The homework solutions is it just they've done it, like rounded it differently?
Yeah, they rounded to 1 digit instead of 2, but on the test I do want you to round to 2, but you should still be able to use them to check your work.
Oh, okay. I turned it in, so I'm gonna go.
Give me 1 second real quick. I'm sure it's cool. I'm just checking everybody's before they head out. Man, it's so much easier to check your guys' homework in class. To just make sure everybody's working and then like look over your shoulder and be like, oh, it's cool, but on here I have to like wait for it to load. Way easier to walk around the room while everybody's working and be like, hey, work more. Or like, hey, slow down, work less. Yeah, this looks good. Yeah, you're good to go.
Okay. Thank you.
Cool. Good luck on tomorrow's quiz. I'll see you then. Well, it's sad that we don't get to do the project. The project for this quarter was part of this chapter. If everything was normal, we would have done the quiz, and then after you guys got it back, we would have worked on the project for like 2 or 3 days. Then we would have done the second half of the chapter's notes, and then we would have had the chapter test. I guess I'll talk about what the project is because it'll be part of the next section lecture that we do on Thursday. But it's a good one. We like measure the height of a building. I'll probably post the instructions for it in case you want to do it at home and like measure the height of your house without actually climbing up on top of your house, which obviously don't do that. But to do the project, you need a protractor at home, and I don't know if everybody has a protractor. Do you guys own your own protractors, or do you guys just use the ones in class?
I have a mini.
I might have one at home, but I don't think so.
I have my own.
Yeah.
Yeah, it would be rough without everybody for sure 100% having these. If I knew that like we were probably not going to go back to school anytime soon, I would have sent everybody home with one or whatever if I was better at that kind of planning. But yeah, you can use a protractor to measure the height of your house. I'll talk about it on Thursday when we do the notes. It's interesting. Just sad that we won't get to actually do the project. It's more fun to do on campus because houses are like a standard height, or if you go on a website like Zillow, you can just straight up look up the height of your house. It's like public information on the internet. But the most fun one on campus was that one super giant tree in the parking lot. You know the one I'm talking about?
Not. I don't think so.
There's one tree right at the edge of the parking lot that is just like ridiculously tall. Like it's twice the height of the Performing Arts Center. You just never like notice it unless you are directly underneath it looking straight up. But that thing is really fun to measure the height of because the answer that you get is wild. In 1 year, we measured it directly by tying a string to a drone and then flying the drone all the way up to the top of the tree and then cutting the string at the ground and then measuring its length with a meter stick or whatever. And the answer that you get is really close, really spot on.